Alright, let's talk about something fascinating, a pure analog inverter. No microcontrollers, no PWM chips. Just 3 passive components. On your screen right now, you see the schematic. We have a standard 12-volt DC power source. Then, a single relay, a 100 nanofarad ceramic capacitor, and finally, a center tap transformer. That's it. 3 components to jump from 12 volts DC to a deadly 220 volts AC. But how? Let's break it down slowly. Here is the magic trick. This is not a normal relay circuit. We are abusing the relay's coil. When you apply 12 volts to the relay coil, it becomes an electromagnet. It pulls the switch. But the moment the switch moves, the power to the coil cuts off. Point to the capacitor. This is where the 100 nanofarad capacitor comes in. It sits across the coil. It stores a tiny bit of charge. When the power cuts, the capacitor discharges, keeping the transistor or the coil active for a microsecond, and the relay bounces back. This bouncing, this oscillation, happens thousands of times per second. It turns the relay into a buzzer, an electromechanical oscillator. Beautiful, isn't it? Now, a serious warning. This is a dangerous circuit. What can you run with this? You can run a small incandescent bulb. You can test an LED bulb. But do not run inductive loads like a fan or a refrigerator. Why? Because the waveform is a modified square wave. Inductive motors need a pure sine wave. This circuit will destroy them. Use this only for educational purposes or to show off to your friends.